everyone. My name is Emily Wright, and the topic of my project is geologic mapping of the in-crop in the Mammoth Cave system in Kentucky. Geologists typically use surface rock exposures called outcrops or remote sensing techniques such as aerial photography to document and record the geological units of an area of interest. Another remote sensing technique is well log analysis, which maps geological units not accessible at the ground surface. Mapping of incrops, which are rock exposures within cave passages, is an underutilized technique to document the geology of a karst area, and unlike well log analysis, which is costly and requires specialized equipment, mapping geological incrops in caves is an accurate and efficient method of mapping a geological unit from the inside. This study uses geological mapping of incrops along with cave survey data to produce georeferenced three-dimensional maps in particular areas of the Roppel section of the Mammoth Cave system. Newly mapped geologic data is used to produce three-dimensional profiles that illustrate the geology and the geography of the Roppel section of the Mammoth Cave system. This extends geological data to areas outside of the National Park georeferenced cave. So something I did not know prior to this project was that Mammoth Cave is actually the longest cave in the world. What a privilege it is to live right next door to it. The map to the right shows the Mammoth Cave system. My project takes place in Roppel Cave, which is highlighted by the red box on the map, which is a 95-mile-long cave outside of the national park, and more specifically at the Dalio entrance of Roppel, which you can see labeled to the right. Roppel Cave also consists of 8 distinct levels, which means 8 different passages, or natural tunnels, each being at different elevations. Figure 2, the farthest image to the right, is of Kangaroo Trail, which is one of those 8 levels. A significant feature shown along many of the passages in Roppel is a rock layer called Joppa, with 2 sections. The first section, Joppa 1, contains a layer referred to as the fossil hash. In a high-energy beach environment, bones and shells get slammed against the coast and broken up into small pieces like hash. That is what created the fossil hash. Wherever sharks had died, their bones, such as their teeth, would get worked upwards towards the beach by the activity of the water, broken up, and would settle with the rest of the broken bones and shells. So shark teeth have become a topic of interest in the Mammoth Cave system because there have been some shark teeth findings within the fossil hash. The idea of this project was to map the incrops, or geologic units, of the cave using cave surveying. To do this, we used a Disto-X, which shoots out a red laser which calculates the distance between the tool and the surface the laser is shooting to. Figure 3 on the right shows what this tool looks like. Figure 4 on the right is of me using this tool to create a cross-section of this specific area within the cave passage. By measuring each distinct feature in the wall, such as where the cave rock protrudes out, you can plot these measurements to create a cross-section. Roppel Cave has already been surveyed, which is why we have maps of its system. In order for us to know where our cross-sections were within the cave, we had to tie our location to existing survey stations, or points along a survey line, that line being the distance between each point, to determine our location and elevation. We could detail the cross-sections by describing the stratigraphy, or rock layers, within our section. In order to compare what we were describing in the cave to what was already been identified in the Mississippian stratigraphic column, we would have to know our elevation. So this is why we tied our cross-sections with existing survey stations. After determining the rock layers and elevation for each cross-section, we will put this data into ArcScene, which is a computer system, to create a three-dimensional map of the Dalio entrance of Roppel, which is a technique never done before in the Mammoth Cave system. The image to the left is of my field assistant, Madeline, who's on the right, and I, on the left, surveying an area called Nag Junction. And the image to the right shows the cross-section I had plotted and drawn after taking the measurements of the walls. Figure 7 on the left is the Mississippian stratigraphic column, and Figure 8 is of the cross-section within Roppel that very nicely shows how we surveyed and detailed the cross-section with the strata as we crawled up through the passage. On the left, we see the Joppel layer, and on the right are the two sections of the Joppel layer labeled in the cross-section. Next, we have the Uves, and then we have the Levias and the Paoli. This is a base map of the Delio entrance of Roppel Cave, starting from the top left at D1 and down to the bottom right at D10 are all the cross-sections we had drawn. As said earlier, the expectation of this project is to create a georeference 3D map in ArcScene, which means the rock layers we determined in the cross-sections and from the survey will be used to create the map and a profile to show the geological data. Further into this project, we hope to create an interactive map in GIS, which is another computer system where you can select a spot within the cave and a cross-section with details of its stratigraphy will pop up. The last part of this project would be to create a story map for educational purposes. A story map is a web map equipped with information about the cave's stratigraphy, cross-sections, and field photos and notes that can be used by individuals to explore the content information of the cave. The 3D maps will be able to be used as reference by speleogeologists and geologists, by those studying the hydrogeology and paleo or past hydrology of the cave, the geologic profiles within the 3D map and interactive map can be used for paleontologic studies, such as for those interested in finding shark teeth within the Joppel 1 layer and those studying the environmental deposition of the cave. Figure 11 on the right is a shark tooth found in the cave. The interactive map can be used for educational purposes. Figure 12 in the bottom right corner is a group of cavers learning of cave formations in a cave in the Tennessee, Alabama, and Georgia, or TAG, tri-state area. The map can also be used for conducting research and for interpreting the cave and its geology. Finally, I would like to take a moment to thank my field assistant, Madeline Broski, and my mentor, Dr. Cambyses, for both helping carry out the data and results for my project. I would also like to thank CRF, SCCI, and the Central Kentucky Karst Coalition for providing me the access and information to Roppel. Here are my references, and thank you all for listening, and I appreciate your time.